how many effects this electric current has? Oh, that's an important question, right? So today we will be learning two different effects of electric current. Are you all ready? Yes. So let's get started. So today we are going to have a wonderful lesson on the topic called electric current and its effects. So my name is Aishwarya Sundaramachandran and I will be a science educator today. So let's get started. So before that, please have a notebook and a pen along with you so they can note down the important points as we are going to discuss multiple concepts. Not only that, please pay attention throughout the class and try to take down the important points. So let's get started. And we are going to start off with the basic contents of the chapter. And here we are going to start off with electric charge. Then we have heating effect of electric current, electric bulb and electric fuse. Then we have magnetic effect of electric current, electromagnets, and finally electric bell. So these are the basic concepts that we will be learning today. So look at it. Oh, we are going to start off with the very first concept, particles. So when you want to talk about particles, it's very important to point out matter. So what does mean by matter? Any object that has mass and can occupy space can be called it as matter. So let's take some examples here. A book, an apple, a bottle of water, all of these are made up of particles. Why? Because all of these can be considered as matter. So matter is made up of particles. But if I take a tiny particle out of it, this can be called it as an atom, the constituent of a substance. Got it? The tiniest particle, it's nothing but an atom here. Got it? Yes. But when you go for the zoomed picture of an atom, we have few more things to learn here. So this can be called it as structure of an atom. So when you look at it, you can see that there is a central portion for it. So the center of an atom can be called it as nucleus. Okay. So inside the nucleus, we have two things. What are they? Proton and neutron. Okay. Proton and neutron. So we are going to keep these things aside. And what are these things which are revolving around the nucleus? These are called electrons. Okay, very, very simple. So electron, proton and neutron. All these particles can be constituently called it as subatomic particles. Please don't forget the term, very important. Electron, proton, neutron. All together can be called it as subatomic particles. And now we are moving towards the next concept. Look at this. It's all about electric charge. So what is the necessity of learning this charge here? Oh, so this proton, electron and neutron. We know that these are subatomic particles. But what about their charges? That's what we are going to learn now. Look at it. What is meant by electric charge? So electric charge is the fundamental property of matter itself. We know what is matter, right? Yes. So this is a fundamental property of matter and the SI unit is going to be coulomb. And what about the charge of an electron? Look at this. Minus 1.602 into 10 power minus 19 coulomb. Very, very important. Look at this. This is negative. Okay, you can see that it is minus 1.602 into 10 power minus 19 coulomb. So that means electrons have a negative charge. Very important. So electrons are negatively charged, protons are positively charged, and neutrons are having no charge at all. So subatomic particle charges also been learned now. And now we are moving towards the next one. It's all about the charge properties. Very, very important. So when you talk about charge, why do we need to learn about the properties? Yes, how do they behave? We need to understand that, right? Yes, so charge properties. So when you talk about the type of charges, you see that we have positive charges and we have negative charges. So positive charge. What is the example? Protons, right? What about the negative charge? Yes, we do have other examples, right? Electrons are negatively charged. But how do they behave? What if I try to keep two similar charges each other? That's what we are going to learn now. So when you look at the very first one, you can see that there are two positive charges coming together. So we have taken similar charges here. So if I try to keep them, what is happening? Yes, they're moving away from each other. That means they repel. And that is what the reason we call The relationship between them or relationship between two similar charges are going to be repulsion. Got it? They repel each other. They move away from each other if we try to keep two similar charges. That happens with negative charges too. If I try to keep two negative charges together, what happens? The same thing. Repulsion. Why? Because we are trying to keep two similar charges. So they are not going to stick each other. Instead, they will try to move away from each other, and that is what the reason we call it as repulsion again. And what about this one? A positive charge and a negative charge. So these are dissimilar charges. So as you consider two dissimilar charges, they are going to move towards each other, right? So they are going to move towards each other. That means they attract. Okay, so two dissimilar charges attract, whereas two similar charges repel each other. So that is what the main property that we need to learn here. And so now we are moving towards the next one. Look at it, it's all about heating effect of electric current. So this is what we are going to learn now, heating effect of electric current. This is one of the very important concepts of the chapter. So look at this, you can see that there is a circuit, right? We have wires, we have a switch here, we have a cell here, we have a bulb here. So I made a very simple circuit out of these components. And if I try to touch the wires, oh, wires are hot, right? Yes, wires are hot. But how? Oh, that's a very important thing, right? Yes, but don't try to experiment this at home. Okay, this has been given for your reference. Got it? Please don't try at your home. Wires become hot. That's where we need to understand the heating effect of electric current. So look at this. So for that, it's very important to learn about conductors and insulators. So what are these conductors? Materials that allow electric current to pass through. So let's take some examples. Metals. But what about insulators? They are not going to let any kind of electric current to pass through. Plastic, glass, all of these are considered as insulators. Very, very important. So now we are going to talk about heating effect in detail. So what is meant by heating effect? When electric current passes through a conductor, the wires become hot. So this is one of the effects of electric current. And the amount of heat produced depends on the material, length and thickness of the conductor. Got it? Clear? And now we are moving towards applications. Where do we use this particular effect? So we have taken two examples here. The first one, electric bulb filament. Okay, so the thin wire gets hot when electric current passes through it. Similarly, the same effect has been used in the part of electric fuse. Electric fuse is a safety device. We all know that, right? So fuse wire can melt on overloading and therefore it breaks a circuit. So these are the two places where we actually make use of this heating effect of electric current. Got it? And now we are going to continue with the same. So here we are going to start off with the very first application of it. It's nothing but electric bulb. Very, very important. Okay. So now let's learn the basic parts associated with it. So parts, filament, it has a glass case and inert gas. Very important. So when you look at this, you can see that the different parts associated with it. Correct? So this black one can be called it as filament. Okay, filament. So this is a thin wire which is made out of tungsten metal. Okay, then you have a glass case. Okay, so this is actually for the protection of the bulb itself. And inside that, to avoid other reactions, what is being filled? Inert gas has been filled. Got it? And that's about the parts of a bulb. And what about this one? The filament, it is made up of tungsten metal, and when current passes through the filament gets hot, and at the same time it starts to release heat and light. So this is a place where the heating effect of electric current has been used. And now we are moving towards the next one. It's all about electric fuse. So what is meant by electric fuse? It is a safety device. And we are talking about the conventional type of electric fuse that was used earlier. Okay. So this can be basically used to break the circuit. Okay. At what condition? On overloading conditions. Very important. Got it? So when you take a fuse, okay, this has a fuse wire. So let this be your fuse, okay, and this has a fuse wire. Got it? So this is known as fuse wire. So let me take a different color so that you will not get any kind of, okay, let this yellow one is going to be your fuse wire. So fuse wire is basically made of an alloy of tin and lead. Very important. And there is one more property that we need to consider for a fuse wire. So what is a fuse wire? It is basically going to melt on overloading conditions. That means it needs to have a very low melting point. And when excess current passes through it, what happens? This fuse wire is going to melt. Okay, so it melts and breaks the circuit. Got it? I hope you're clear. It's a very, very important one. So this is where the heating effect has been used. So when you break the circuit, what happens? The appliances can be saved. But there is a problem associated with this electric fuse. Why? Can anybody tell me what is it exactly? What is the basic disadvantage of this electric fuse? Why? Because every time there is a short circuit, the fuse wire melts and breaks the circuit. But this has to be replaced every time. For the next use, it's very important to replace it. Okay, so replacement is a disadvantage here. And now we are moving towards the next one. It's all about appliance fuse. So nowadays, almost all the electrical appliances are inbuilt with this appliance fuse. So it is also considered as a safety device and used to break the circuit on overloading conditions. And fuse attached to individual appliance itself, and this also has low melting point, and when excess current passes through it, what happens? The fuse wire melts and breaks the circuit. Okay, so this is a heating effect of electric current. So now we are going to learn the second effect of electric current. It's nothing but the magnetic effect. So here I have taken a similar circuit, okay, and electric current is passing through it. I have placed a small needle there, and I can find that there is a deflection in it. That means the wire is producing a magnetic field around it. That is what the reason I can see there is a deflection in the needle part. Got it? Clear? I hope you are clear with the point. So if there is a deflection here, you can find that it's nothing but due to the magnetic field produced by the wire. And if current direction is reversed, what about the direction of this deflection? This also can reverse. Now we are moving towards the next one. It's all about miniature circuit breaker. Very, very, very important. MCB, miniature circuit breaker. So in most of the houses, now the conventional type of electric fuse has been replaced with MCB. Why? I'll tell you. Okay, so this is also considered as a safety device used to break the circuit on overloading condition. Okay, so that means the function is same. But what is different here? There is a bimetallic strip gets heated and deflects by bending, and therefore electromagnets separate the contacts and therefore it turns off automatically. So this is actually an automated way of breaking the circuit. Clear? It is an automated way of breaking the circuit. So that means no fuse wire is going to melt here and break the circuit. Correct? And therefore, you can say that if there is an overloading condition, automatic turn off happens here. But when you want to restart again, you have to do it manually. Clear? And this is the magnetic effect of electric current. So, and now we are moving towards electric bell. Very, very important. So, when you talk about electric bell, the main parts are electromagnet, switch, hammer and gong. So when switch is on, what happens? Current will definitely pass through the circuit and iron core becomes an electromagnet there. Got it? So due to this, it activates and generates magnetic field. So hammer is the part which is going to hit the gong and create sound. Okay? So hammer strikes the gong and produces sound. And what about the next one? Then the contact breaks. Immediately the contact breaks and hammer moves back to its original position. Got it? So that to complete the circuit again, and by the time the hammer touches the gong, and therefore it produces sound again. So this is going to be a repeated process. So this is the way the electric bell works. Got it? Clear? And now we are going to talk about electromagnet. So what is meant by electromagnet? Artificial magnet which produces this magnetic field. Around it, only when electric current passes through it. So when electric current passes through this, then the magnetism will be produced or magnetic field will be generated around it. But what if there is no current passes through it? No magnetic field produced. Clear? That's the same way we need to learn this. So if no current passes through it, no magnetic field will be produced, and this is known as a temporary magnet. So electromagnet is a temporary magnet. Only when the current passes through it, it has magnetic field around it. Got it? If there is no current, no magnetic field will be produced around it. Clear? So that's how we need to understand it. And finally, we are going to talk about the safety precaution. Do not touch the electric wires with wet hands. Very, very important. Don't try to play with electrical appliances or wires. Very important. And do not touch broken wires with bare hands. You may get shocked. Okay. So this can be very, very dangerous. Don't try to take risk at your home. And say no to multiple plugging into a single socket. Look at it, how many plugins have been made. So this is actually a wrong way to do it. So don't do that. Okay. So these are the main safety precautions that we need to prefer while working with electrical appliances. And now we are moving towards a summary part. We started with electric charge, then we finished heating effect of electric current, when we discussed the electric bulb and electric fuse, magnetic effect of electric current, electromagnets, and finally electric bell. So these are the topics that we discussed today, and I hope everyone liked it. And we are going to come up with an amazing class next time. So till that, have a good bye and thank you so much.